Okay, so that window is frozen. And the main RC3 window is frozen. Notice the laser is still going on about its merry way. So there's definitely a buffering problem or something in that. So this is Lightburn RC3. We're still hung up. You notice that memory is at 56%, CPU is 31%, SSD, not much is happening, very little on Wi-Fi, and the GPU is basically just sitting there. But if we tilt back here and look at the app is still frozen. Notice not responding. And yet the job is still running perfectly. So that's an interesting puzzle. We'll get this video uploaded to Lightburn and see what you guys think. Again, this is RC3. Okay, this is the stock display for an A or an X70. And this is a useless display. The following notes when I put them together is the changes that would substantially improve the value of this display to the customer. So as promised, we're now going the opposite direction in the layering testing we were doing. And we're using a different material. This is a B grade 5mm Baltic birch, so it's average quality. This is typically what I use for doing a lot of panel related work or making boxes and things like that. The goal here is exactly the same as it was on the previous garbage wood, is to sit down and determine where the boundary conditions are. Where can we run maximum sharpness in the image, maximum depth in the image, without doing overburn. Okay, very interesting. This job finished, and it went to home, completely finished the job, and yet it's frozen. This is still frozen. It's just sitting there. RMC, I was curious about your question in Z, and if you look carefully, you will see that Z maximum travel is 120 millimeters, but steps per millimeter is 1.600000. So you have many more points of resolution in Z-axis than you do in X and Y. So again, properly programmed, Z can be programmed just like X and Y. Most applications like Lightburn, of course, aren't really good at this, but the laser has the capability. And if you just simply go hand edit a Gerber file, you just go to the G-code line and put in the correct information for how you want to move Z, you can do it with very, very high resolution. Basically the same as the X and Y, because they'll all use similar servers and so forth. So I think that adequately answers the question of Z resolution versus X and Y. This was done at 12,045, 2.5, 254 DPI. This is the first pass. This is Baltic birch. It's 4.5 millimeters roughly. I just sprayed some clear Rust-Oleum clear coat on. I had previously, yesterday, had coated both sides of the board with one coat of Zinzel, which is a shellac, and let that dry for 24 hours. And so now we're continuing our testing with now increasing power as we move forward instead of decreasing power, so we can see where the boundary conditions are for getting the sharpest graphic image. This particular image was taken by NASA, so it has really, really well-defined grayscale. And so it's very useful for sitting down and analyzing how effectively we can do engraving of an image on a surface. Okay, we're starting our second pass. One of the things you notice if you look, that board is very warped. And so it's going to be very interesting to see how the focus changes and the depth of the image, where the curvature is the greatest. We are now running on release candidate 4. I just set that up about 10 minutes ago. Already, release candidate 4 is not handling cameras properly. It went through all the device settings and everything correctly. It remembered the presets and so forth, so we're doing okay there. One of the things I'm testing for is, just as I was working on the last release 3 testing, the screen actually froze, but it ran 28 minutes and completely finished the image. So that's a really bizarre bug, but we'll keep watching out for that one. I'm going to send an update to the Lightburn folks tonight and see if we can get a better handle on it. The interesting thing is when he fired up Perfmon in the Microsoft performance management tools, system was basically lumping along at 31% for the CPUs, used 56% of memory. There were no memory leaks spotted. Disk I/O was almost non-existent, and so was network I/O. So there wasn't a buffering problem, but there was a problem between the spawn process, which is the process that's actually running the job, and the user interface. So that's what they need to investigate. The other thing we noted is when we fired up both RC3 and RC4, a lot of times you have to fire it up twice because it forgets the laser is on there. So there's a little work that needs to be done on the USB side to make sure it properly acknowledges the port's active. Okay, for RC4 we get another bug. Notice the busy time remaining counter is no longer working. In 3 it worked fine, and you also notice the little busy icon. So there's some issues somewhere in there. This is RC4, and notice it's doing the same thing that 3 was doing. What I did is I hit the cuts and layers button, immediately went busy, and now it's just sitting. And what's funny is the job just completed. So there's definitely a synchronization problem. The spawn process, which is actually driving the Gerber code to the laser bed, is working, but the interface is not responding. Okay, here is our pass at 12,070. I had just sprayed previously a little bit of clear Rust-Oleum on there, and we're really starting to see very nice photographic, very detailed 3D images. So it's really coming out nice. I'm going to leave this pass and cut it out, and I will probably do another one, and we'll try slightly different number of layers, maybe add 2 more at a quarter power difference between them to see if we can even further increase the depth. But the thing to notice is there's no real burning. We're just now getting a very nice browning. And of course the NASA images are exceptionally detailed in their grayscale depth. And these give you the result of a really nice image.